So an important experiment in microbiology is a growth curve. And a growth curve with microbes is something where you start microbes at a low concentration and you're observing it over time. And you determine how many organisms or what the optical density is during that time, and then see how steep the slope is. The slope gives you an indication of how fast the organism grows. And for example, if you want to test out a new antibiotic you're developing, you want to see if the antibiotic affects growth or even kills the organisms, which is possible to do this experiment for as well. So the growth phase of bacteria is fairly straightforward. You see the lag phase at the bottom, where it goes really slow. And this is the lag phase. Then you have the fast growing rate here is the log phase, the logarithmic growth phase. This is the log phase. And then you have the stationary phase, where there's not much growth going on. Sometimes you see a little drop at the end, which is the death phase, but that's not always obvious with the different experiments you do. You can see that your x-axis, your y-axis is in optical density, but it could also be in CFUs per mil. That would be if you plate out different samples and dilute them at different times of your experiment. And then you have your x-axis in time in hours. So now we want to determine the generation time, which is an indicator and a numeric evaluation of the speed of growth. So if you have your growth curve here, you want to determine the steepest part of your curve and then determine what time it crosses the axis at the beginning and at the end of your steepest part. So you can see that about 2.5 hours, 2 hours and 30 minutes, and then at about 7 hours is the steepest part over. So this is your T1, and this is your T2. Now you need to get the corresponding optical densities. And you just go over to your y-axis, and the optical density at time 1, optical density 1, is approximately 0.15. And the optical density at the highest point of the steepest part is approximately 0.5. So your OD2 will be 0.5. So now you need to use the formula which I've given to you. So your generation time asks for time 1, time 2, and then optical density 2 and optical density 1. So we can just plug in the numbers we just determined from our graph. And T2 is 7 hours, and T1 is 2.5 hours. And the difference from 7 hours minus 2.5 hours is 4.5 hours. Then we multiply this by log 2 and divide this by the log of the optical density 2, which is 0.5 minus log of 0.15. And then you calculate this, and you get your generation time. Going back to your graph, you can see that this example growth rate was your control. So you have pretty advanced growth of the organisms. For example, if you would now add your treatment at time 0 to a different well of your spectrophotometer, you could probably determine that your growth changes over time. And if you have different concentrations of your antibiotic, you probably see something like this. That would be concentration 1, concentration 2, concentration 3, concentration 4. And you can see the inhibitory effect of your treatment on the cell growth. You will get a growth rate for each of these different treatments, and then you can compare it and do statistics on it and determine if it is statistically different. Hope it makes sense.